Namaskar. Today, let us learn about cathode ray oscilloscope. Let us learn how to measure a signal in a cathode ray oscilloscope. Here you are viewing a function generator and a CRO. So, function generator is an input device. So, from the name we can understood function generator, or it can be called as signal generator. So, here it can able to generate a sine wave, a triangular wave, or a square wave. So, signals can be generated by using the function generator. Here we can adjust the amplitude and frequency of the signal with the help of amplitude variation and frequency variation. So, for example, so here it is given millivolt reading and volt. So, in this, for example, we have taken 2 volt, and frequency we have the range hertz and kilohertz. So, we can use either hertz or kilohertz. If you change from hertz to kilohertz, you can see the frequency is increasing. So, I keep around 600 hertz. Now, let us see how to measure the amplitude in the CRO. So, here you can see the voltage division. So, CRO you can see here the display. So, here we have x-axis and y-axis as we may plot in the graph. So, it is just a graph sheet. So, here origin 0. So, we can refer from 0. So, the scale reading changes like this: 0.2, 0.4, 0.6, 0.8, 1. Now, we can measure how to take the readings in the CRO, how to take the voltage output from the CRO. So, for example, I give 2 volt in the function generator, 2 volt in the function generator, and I keep the voltage per division as 1 volt per division. So, if I keep 1 volt per division, I got 1 volt per division. So, for 1 division it is 1 volt. So, here in order to measure the amplitude, so I need to measure the amplitude of the signal. Now, let us in order to measure the amplitude, I use this function. So, I keep off the sweep time. Now, I take the amplitude function here. So, here I take 1 volt per division. So, here you can see, so it varies from 0. So, from starting from 0, 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2. So, I give 2 volt. So, in the CRO I can measure 2 volt at the output, right. So, if you remove this sweep time, you get the sine wave as it is. So, in this way we can measure the amplitude. If I change the volt per division, you can see again I off the sweep time. Now, I change the volt per division to 2 volt per division, 2 volt per division. So, for 1 division it is 2 volt. So, within 1 division it is 2 volt. So, here you can see from 0 we get 0.2, so 0.4, 0.6, 0.8, 1 into 2. So, it is 2 volt. So, I give 2 volt here. In the function generator, I give 2 volt. So, I get 2 volt measurement in the CRO. In this way, we can measure the volt per division. Now, let us see how to measure the time per division. Now, I remove the sweep time from 0, from reference of 0. Now, I keep time per division as 1. So, here you can see the scale milliseconds, and here the scale is microseconds. So, if I keep it in 1, so it is 1 milliseconds. So, for 1 division it is 1 milliseconds. For 1 division it is 1 milliseconds. So, I keep 1 milliseconds here in the time scale. Now, I measure in the x-axis towards the x-axis here. So, here it is 0.2, 0.4, 0.6, 0.8, 1. So, it is 1 milliseconds covers here. So, we have to measure negative and positive. the total time period covered by the negative and positive cycle. So here it is 1 and then 1.2, 1.4, 1.6. So it is 1.6 into 1 milliseconds. 1.6 into 1 milliseconds. Now I change the time scale to 2. Now see what happens. So here negative and positive, negative and positive. So we have to take the readings combinedly, negative and positive. So it is 0.2, 0.4, so 0.6, 0.8 into 2. So again it is 1.6 milliseconds. We have to combine negative and positive, so 0.8 into 2. If I keep it 1, so it is 1.6 into 1. If I keep it in 2 milliseconds division, then it is 0.8 into 2. Again it is 1.6 milliseconds. So if you convert in frequency scale, so it is 1 by t. Whatever the frequency you apply, approximately you will get the same frequency. In this way we can measure the voltage and time using CRO. Thank you.